Hey guys, welcome everyone to the second deep dive of Open Web Foundry 7 with Phil Mataras, the founder of ArDrive. So Phil's been a longtime community member and founder, so we're really happy to have him here to talk more about this project and also how you can leverage it with your own project that you're building for this current cohort. And as always, we'll be having a mingle session afterwards. So if you guys have any questions, yeah, we'll be around. With that being said, Phil, I'll let you take it away.
Great, thanks, Jesse. Let me share my screen. Okay, is that good?
I could see the Gather UI. Yeah, perfect. See the presentation.
All right, cool. Well, great to see you all again in our favorite 8-bit world. Yeah, my name's Phil. Today we're going to be talking about ArDrive specifically. And I know some of you probably attended my session last week. I did some high-level discussion around ArDrive and RFS. Probably go through a little bit of that, but we have a lot more to come. Definitely going to get a lot deeper. We're going to start with the ArDrive platform overview, right? The different levels, the things that we have put together that make up this platform. We're going to get really deep into the Arweave file system, which is the data protocol that we've created. So we'll talk about why we had to make it, some of the motivations around it. We'll get into the privacy aspects, the data model, how things reference one another, the different RFS actions that you'll be able to perform. And yeah, just really how that's all put together and why that's important for apps like ArDrive. I have a little demo that we've prepared. Our CTO Ariel Melendez was able to get into ArDrive-Core and show you a couple different ways how you can use that. And then we'll finish it up just talking about how RFS can be extended and some of the other things that we're looking at and maybe hoping to get some community feedback on around how this data protocol can be made better and work better for the community and the developers who want to use it. So my name's Phil. I think a lot of you probably seen this slide, right? Founder of ArDrive and RAO. Used to be a systems architect, dealing a lot with traditional IT, legacy type systems in the cloud and on premises. A lot of document management, collaboration platforms, some search, email, and yeah, always with an eye on like kind of the infrastructure side of things. That's what got me into crypto and communities like Arweave was the mining and kind of the node operations aspect. And yeah, been in the Arweave community for a while. Love it so much. I quit my job a couple of years ago to found ArDrive. And I started ArDrive in the community with a simple mission and purpose, right? So our mission is to just get this permanent storage into the hands of everyone. It's such a powerful technology. And there's so many people out there with the need to store data forever. It's our mission to get really easy to use applications and tools and whatever necessary to those people so they can use this great technology. And we have this community around us in order to support and learn and inspire one another to actually build this platform and enhance the awareness of our overall mission. So the ArDrive platform itself has a few different components and layers, I guess. It starts with our web application and other native apps that are coming down the line. But ArDrive is primarily a web application right now. And that's what you would expect for your Dropbox-like app. So it's intuitive, easy to use, supports a Web3 login. And that's just for your kind of retail use case, right? Someone who's not going to know what Node.js is or get into a terminal. For those people who are familiar with more advanced tools, we offer a command line. And that's something that you could use to automate your workflow or produce some scripts to do all your batch uploading or downloading, creating custom manifests, etc. Those tools are built off of our core libraries. We actually have one in Dart and one in JavaScript or TypeScript. We're going to be talking about the TypeScript version later on today. But our core libraries is, those flexible, patterns and methods to integrate with RFS and do your uploading, downloading, finding of data, and yeah, creating an application that natively fits with ArDrive. And of course, ArDrive is really powered by RFS, the Arweave file system, bringing it really deep into that. But that's the information architecture that we apply to all the transactions that are uploaded to Arweave, and that lets clients model those transactions like a file system. And there's some protocols around how that data is read and manipulated to give some mutability to Arweave. And of course, Arweave is the bottom layer, right? Everything uploaded through the ArDrive platform is stored forever on the permaweb. This isn't the session to get into the details of Arweave, but we're certainly going to talk a lot about it. This platform in and of itself, as I mentioned before, we have a community, right? The ArDrive community. So using the ArDrive platform does incur a community tip of 15% of all the uploads that are made through the platform. And that tip goes directly to a random ArDrive community token holder. Paying this tip, though, does get you into community programs that we offer, right? So like right now we're doing Inferno, which is our latest usage mining rewards program. Basically, you upload files through ArDrive Web, CLI, or Core, and you're potentially rewarded for it with ArDrive tokens. So it's just another benefit of using ArDrive is because you can now take part in this community, and there's kind of other incentives that we kind of roll into that. But now let's just get into each layer of the stack. So the ArDrive Web app, again, I would hope a lot of you here have given it a shot. It's open source. If you wanted to look at the code, it's all in Flutter and Dart. But there's certainly some patterns you can probably glean out of that. It is mobile friendly, right? You can access it on your iPhone, Android, as well as your desktop, Chrome, Firefox, Brave. There's no sign up. You just bring your own wallet, whether you have a JSON file or you use RConnect. And we try to make it as intuitive as possible. We try to demystify some of the blockchain terminology, and yeah, really target your retail type use case. So that doesn't mean there aren't some more advanced features in the web app, like being able to create an Arweave manifest, which is something else that you can do. Any files that you upload are either totally private, and you're the only one who has access to those, and you're the only one who has the ability to share those keys with other people, or your files could be totally public. Both cases you can share, right? Whether it's your public drive, your private drive, public files, private files. Very easy to share with friends, family, and whomever you have to. There's no monthly subscriptions, right? Of course, this is Arweave. It's pay once, store forever. So we don't have that in any model in the ArDrive-Core, ArDrive CLI, or ArDrive Web. You bring your AR, you pay as you upload your files, and yeah, no monthly fees. And then it's governed by the community, right? So certain decisions around things like fees and other things relating to tokenomics are managed by our profit sharing community through Community XYZ. And that applies to not just ArDrive Web, but our other apps like the command line interface. Again, this is another platform or another application that we created towards the tail end of last year after we released the ArDrive Web app. This is another open source app. It's written in TypeScript, uses ArDrive-Core.js. It's a Node.js based app. It's very easy to script in your terminal. Every command that you run provides a nice JSON formatted output that you can then do other things to or save. There's a local cache of all the metadata that you pull with the CLI. So if you're getting drive or file folder information, you don't have to keep querying GQL to get that. It stores it nicely in a cache. It does support some more advanced things like creating custom manifests that can reference any ArDrive or Arweave transactions. You can do bulk uploads, right? The ArDrive Web app does have some limitations with the sizes of files. ArDrive Web, for example, you can't upload a private file bigger than 100 megs. You can't upload a public file bigger than a gig, or I think it's maybe 1,200 or so megs. But those limits are raised in the CLI. I think it's a 2 gig limit for both of those. We're working on increasing that so there's no limit. But yeah, so it supports those more advanced use cases and bigger data use cases. And it also lets you download and sync all of your drive information locally. You can't do that in the web app if you just wanted to, for example, download your whole drive. CLI lets you do that. And of course, it supports every other RFS action, whether it's creating folders, drives, moving files, renaming files, moving folders, all of those kinds of things. Also has some other neat network utilities. For example, if you want to create transactions or wallets or create a 12-word seed phrase, if you want to, create a transaction in an offline environment and then pass it to a connected environment, the ArDrive CLI lets you do that. Checking the status of transactions in the mempool. So we try to, our core team, the core drivers, as we come up with needs to help us in extra utilities, we try to put that into the CLI. So then, the broader community can also leverage those. It's also, worth mentioning that the CLI, the web app, and ArDrive Core all use what we call direct-to-network bundling. So that's basically where the client uses the ANS 104 AR bundle standard to create those bundles and just send them right to the network. So you can't pay with other cryptocurrencies. You still need to pay with AR and bring your own wallet to support that. But it does mean you get the cost advantages of packaging tiny transactions into one bundle. And it also means that you have some better reliability. Because again, if your transactions are tiny and you're submitting a lot of them, you could potentially flood the network, and those small transactions might not get mined. So definitely recommend anyone to use the bundling standard in the apps that they're building. But ArDrive Core, right? I mentioned before, it's also in Dart. We primarily work with our TypeScript version, and that's also in the CLI. But ArDrive Core, does give you some advantages over, for example, Arweave.js. Sure, ArDrive Core is kind of built on top of Arweave.js, but we did rewrite some things ourselves, and we definitely added some things, like, for example, uploading via ArDrive Core. We send more than one chunk sequentially, so uploads are a lot faster. We introduce all the end-to-end privacy that RFS brings you, so you can have private data uploaded through ArDrive Core. All the advantages of creating manifests or performing any other ArDrive actions, or I should say RFS actions, can all be done through ArDrive Core. And the other benefit is, again, if you're using something like our core, when you upload your data through it, it's going to get tagged with RFS, and it's going to be viewed in the ArDrive web app. So that's something that you're going to get simply by using core. Even if your app has its own interface and look and feel and purpose, you could benefit from any of the other ArDrive apps or any other RFS-enabled app, because that's really the benefit of RFS, right? It's like this data layer that every kind of application can kind of read from. So that's another really big benefit. And of course, we like to provide really good support for any team or developer who's using ArDrive Core or any of our products, right? Whether that's support through our Discord or more specialized support through ArDrive Valet. And ArDrive Valet is really for those who have like great ideas or a lot of data, but you're not sure where to start. Whether it's with Arweave or ArDrive or Web3, just you're not sure where to go or what to do. Or maybe you are a developer and you're doing a lot of work on your smart contracting side, and you just don't have the time to figure out how to plug it into ArDrive. That's really where our Valet service comes into play, which is just a white glove service. We work with you. We look at your requirements. If it's just to upload some data, whether it's an NFT collection or other information you're looking to archive, we can just help handhold you through that process. Or if you need advice and guidance on building your solution, maybe something that's a little bit more of a deeper relationship, a deeper level of collaboration with our team, right, above and beyond what you get just in the Discord, we're here again to help. Not everyone might be comfortable just going to a public channel and asking for help around some things that they want to build. So yeah, this is again not really a part of the ArDrive. The support that kind of comes with it. So now let's get into I think the most interesting layer, which is the Arweave file system. And this is really the protocol that ArDrive uses. And if you think of Arweave as this kind of world hard drive or data store, Arweave file system is a way to classify and organize all the information on it, right? And this was something that we kind of had to do. When you have a file system on your computer, you can change things. You can move files around. You can rename them. You can organize them into hierarchies. When you submit a transaction to Arweave, you don't get any of that. You get transaction ID, right? And you can apply some tags to it. But you have to decide what those tags are going to be. The Arweave protocol doesn't specify that. So when we first released the ArDrive beta web application, we really had to think about the information architecture and how we were going to model this data so we could, create this drive state. So we can represent your transactions as files and folders and drives. So we had to create this append-only data model, right? Because you can't change data once it's Arweave. You can only append new changes in order to create the state of a file system. And this state can be constructed by any client that's following the RFS protocol. So ArDrive is a client. ArDrive Web is a client. ArDrive CLI is a client, right? We're working on a mobile app that is a client. We had somebody, build an application that integrated with a private drive and pulled data and decrypted it for their users. That's another example of a client that's integrated with RFS, right? And clients that integrate with RFS can get all of these benefits that we've had to build for ArDrive, right? Because again, for a file system, you need to be able to create new versions of files, right? You need to be able to rename and move and organize or apply additional metadata. File systems aren't just public to the whole world either, right? That's another powerful thing about Arweave, is that it's this this public data layer that anyone can read from. Well, sometimes you don't want your data to be public. So we had to come up with an encryption process that isn't centralized or relies on someone else holding custody of your keys. So RFS includes that capability to encrypt and decrypt using keys that you're bringing with you, right? Arweave keys specifically. And then, ultimately RFS is an information architecture. It's a specific set of tags that are applied to transactions. Those tags can all be queried by any application using GQL, right? So it's really easy to find this data, whether you're an app like ArDrive or someone just trying to read some of that information or do some data and analytics and understand how many files have been created or folders, et cetera. The data model that makes up RFS is meant to be really flexible. We do that by using what we call entities to represent this file system state, right? An entity is, for example, a drive, a folder, a file. Each entity has its own real structured and defined schema. So some fields that we track about that entity. And the real important thing that we add is a unique identifier to each entity in RFS, right? We use UUID v4 for that right now. So if you upload a file, it gets its own file ID. If you create a drive, it gets a drive ID, folder ID, and those are all UUID v4s. In order to support this append-only data model, we wanted to split the metadata transactions, or we want to split the metadata about a file. So for example, if you were to rename or move or edit metadata about a file, we didn't want you to have to re-upload that file data itself. So what we ended up with is what we call an RFS data transaction and an RFS metadata transaction. The metadata is split between GQL tags. So like, for example, the drive ID, parent folder ID, file ID, Unix time, app name, those are all just GQL tags that you can query against. However, some metadata needs to be private. And we didn't want to try to encrypt data and stuff it into a GQL tag. So some of the RFS metadata is actually in a JSON file that's uploaded along with the RFS metadata transaction. And things like file name or content type, or last modified, some of that is private, right? So those JSONs we actually encrypt if it is a private drive. So nobody else can see that metadata, right? You can still see and query by things like identifiers, like the IDs, but that's not leaking any sensitive information. So that's why we maintain that split. And yeah, essentially files are one transaction for data and one for metadata. In the case now, those are bundled anyway in a single bundle. Previously, those were, two layer one transactions that were made. But now they're all contained kind of atomically in a single bundle. Whether there's other files in the bundle as well, or if it's just a bundle of one file with its metadata. Okay, so one of the real important things about RFS and the value adds is the privacy. So maybe let's just walk through the encryption process that we use. So when you create a drive in ArDrive, you get to specify if it's public or private. If it's private, you need to provide an additional drive password, right? And what we do is we take a signature from your wallet, whether that's a JSON file or RConnect, and we do a hash-based key derivation along with your password, that drive password that you specify. Right now in the ArDrive Web app, when you log in, you specify one password that's used for all of the private drives that you create for that wallet. That's kind of a limitation in ArDrive Web. The protocol supports a unique password for every drive. Okay, so after we get the signature and we take that password, we get what's called I forgot here. The signature is of the actual drive ID, right? Which is that UUID v4. So that's the unique value that's getting put into the signature that we combine, with the drive password to produce the drive key. The drive key is used to derive the file key for each file in the drive. So you figure you have one master key that can encrypt everything in the drive, and then each file gets its own unique key. So if I share one file with you, you'll only be able to access just that one file because I'm sharing that one file's key with you. Versus if I share the whole private drive with you, you would then have access to the drive key, which gives you access to all of the files that are contained within it, right? So we create these file keys based off of the drive key and the file ID for each file, right? It's another UUID v4. And then we take that file key and we do an AES-256 GCM encryption of the file's data, right? And yes, it's the file's data, but it's also any of the metadata associated with that file goes through that same AES-256. Get asked a lot like, oh, is this quantum proof? All the research nowadays suggests that yes, AES-256 GCM is quantum proof. Now, who's to say what happens in 100 years? This is a little different than asymmetric encryption algorithms, which will definitely have some problems in the future when quantum computers come around. So yeah, we really wanted to make sure that this kind of encryption was as future-proof as we can make it, right? So ultimately, you end up with an encrypted blob of file data. I think we tag it as an application octet stream, and that's uploaded to Arweave, right? The cipher IV we include in a tag in order for apps to then grab the cipher, assuming the user's logged into that app with their wallet and drive password, the app can then decrypt that data. So it's also really important to point out that all this ends up on Arweave, right? So you have encrypted information on Arweave. You will never be able to change the key for it. You'll never be able to, somehow decrypt it and re-upload it with a different key. It's immutable and it's permanent. So it's really important to just understand that whenever you're trying to build any private solutions that are on the permaweb. So RFS, as I was saying, is broken down into drives, folders, and files. The drive is that top level logical container, right? They can be public or private. There's no concept of ACLs or permissions yet, but that will apply at the drive level because it does act as a security boundary. Sorry about that. We've got some meetings going on. And a drive entity is just a single metadata transaction, meaning you don't have to supply your own data or upload a file to create a drive. It's just one metadata transaction that has the information about that drive. Same thing like a folder, right? A folder goes in a drive, right? Folders are collections of files or other subfolders. And again, those are also just a single metadata transaction, really small, made to the network. And then files are a combination of the file's data and then the metadata that references that file, right? The file's metadata transaction basically has a pointer that just points to the data's transaction ID. So these are kind of the three main entities that make up RFS. Can't skip. And yeah, so you can see how drives can have multiple children, right? Whether folders or files, but drives cannot have child drives, and drives have no parents. Folders can also have children, right? As well as parent folders. Right? Folders can have subfolders. And then each file entity references its data, as well as its parent folder, as well as its drive, right? So this is it kind of builds this relationship between these entities. And, ultimately, the file data, you'll see, is the one piece that doesn't have a file ID or a drive ID or, isn't related at all to the rest of the schemas. And that was on purpose because we really wanted RFS to be able to connect to any Arweave transaction that's been made and not have any specific requirements for that transaction. So it's not to say that you couldn't, if you wanted to, or if in the future maybe we decide to do this, but maybe file data does, for example, get its file ID, right? But that is not a mandatory requirement for RFS. Right? RFS file metadata transactions can always reference just a vanilla Arweave transaction, no matter where it is. And I think that's a really unique value prop that we'll talk about in a minute. So to create a drive, right? Let's maybe look at some of the fields. I'll go through one by one, and then we'll see some repeats. And yeah, so a drive, again, is public or private. If it's a private drive, some additional tags are added to indicate that it's private. And a drive transaction is, an Arweave transaction with some GQL tags and a very small JSON that includes some of the drive's private metadata. So every RFS transaction includes the RFS version number. Right now we're on version 0.11. That was the first version that we released in September 2020, maybe October, November, some time frame around that. If it's a private file, you'll see we have to indicate its cipher, which, same before, is AES-256. Right? The initialization vector is included if it's private. All drives will have either an application JSON if it's public, or an application octet stream if it's encrypted. We also include the entity ID, right? In this case, it's drive ID. We indicate if it's public or private. There's a tag for drive auth mode. This one, there's only one value that could be put in here right now, and it's password. But what we wanted to try to keep room for was other authentication types made towards private drives. But for now, that's password only. And then we also include the Unix time, which is when the client writes the transaction. Not to be confused with the time of when the block was mined that has that transaction. That's really the canonical time for that. And then the data JSON itself, which includes the drive name, right? And the root folder ID. So remember, files, their parent has to be a folder, right? You can't just have a file with a parent of just a drive. The file has to be in a folder. So each drive has to have a root folder. This data JSON is encrypted if it's a private drive, so nobody else will know what that drive name is or which root folder that private drive points to, right? So when you're creating a drive, as I said before, drives have to have a root folder. So you typically create them both at the same time, right? When you're building a folder, you're going to reference a drive ID. If it's a folder that's not a root folder, then it'll have a parent folder ID. If it is a root folder, then there's no parent, right? And you'll see the similar, those same tags on a folder metadata transaction like RFS. And now if it's private, the cipher information, folders are just metadata. So it's either an application JSON or octet stream content type. We reference the ID. We call it a folder entity type. And then it has a folder ID, right? It's a folder entity. So it has a folder ID, which is another UUID v4. And then the data JSON for a folder right now is just the name. So there's no other metadata that we're capturing for a folder at this moment. And then finally, when you're creating a file, you're going to create a metadata transaction and a data transaction. Your file data, right? The real cost of the file is from the data transaction. So yeah, create the file data transaction first. If it's private, it'll have those ciphers. You always want to define the content type for that file, because that's what the Arweave gateway will use to preview it. And then after you have the transaction ID for the file data transaction, you then input that into the file's metadata transaction, right? So you'll see here in the data, oh, I can't highlight this, but you see in the data JSON for a file metadata transaction, we have its name, its size, its last modified date, its content type, and the data transaction ID of the data that this metadata is pointing to, right? So ultimately, this builds this relationship of drives pointing to folders, pointing to files, and yeah, this kind of hierarchy of data. You can connect this even further, right? So I was saying before that technically an RFS file metadata transaction can reference any Arweave transaction that has been made. So you can imagine having some transaction made through a social app or through a different kind of uploading service that's still shown in one of your drives, right? You can even take it further and link other RFS entities in your drive. So this isn't available today, right? But you can imagine a user saying, hey, I have this other file that's in another drive, or this person shared a file with me, or a drive or a folder. I have its ID. I can make a reference to that, or a symlink or something to that RFS, to that entity ID in my own drive. So you're really building this web of connected files and folders that have been, created anywhere throughout the permaweb. So after the data has been uploaded, it's all found via GQL. And that's whether you're, for example, querying for all drives for a user. You're using the wallet's public address to get all that information, or if you're searching for the root folder of a particular drive, or if you're querying for all of the file and folder entities for a given user for a specific drive. So these are all queries that you could structure yourself. ArDrive CLI and ArDrive-Core comes with these kinds of queries. I shouldn't say the queries, that they're obfuscated a bit more, but for example, if you wanted to list all your drive information, or list all the drives of a user, or get the revision history of a single file, these are all things that you can do in our tools, or make your own GQL queries to get this information. You can also do things like, putting additional block heights to kind of constrain your searches, or all the data uploaded through ArDrive are in bundles, right? So if you needed to query by the bundled in tag, you can do that as well. So on top of uploading your data and reading it, RFS offers some mutability, right? Some other write actions to help you organize your file system. So you can edit drives, folder, and file metadata, like the name. That's really the only metadata we're tracking right now, is just name. So it's called rename, but figure that could be the editing of any metadata property that you add. You can move files in folders, right? So let's say you uploaded something and you put it in the wrong area. You can organize things and move them around. That's particularly helpful when you're using manifests, if you want to change the paths of things. You can update files, right? So say you uploaded a document and you made a change to it. You can just upload that document again with the same name. You'll create a new revision, and you'll have access to all of the old revisions of that file, right? It's an unlimited version history. So that's pretty powerful to establish kind of a chain of changes made over a document or something like that. And it's not available today, but something that we're also working on is the ability to hide stuff from your drive. Again, hiding is just another type of tag that can be applied. And again, we think that this just gives users another option to declutter and maybe hide some unneeded things in their drive. Okay, so now we have a quick demo with Ariel, our CTO, and Andrew, our community strategist. This is something that we recorded the other day, but Ariel is going to dip into ArDrive-Core and just give a quick demo of a small app that he made that uses ArDrive-Core. And he does a couple things. He'll create a manifest and just kind of show you guys a little bit how it works. So let me open this up here. Let me turn my sound up.
What if you wanted to write your own application that takes advantage of both the power of RFS and Arweave manifest?
Yeah, great question, Andrew. So, ArDrive's CLI is itself powered by the ArDrive-Core.js library, which also is open source and also has a great README that I'd invite people who want to go ahead and write their own application to go read about and learn and see how easy it is to get started with RFS. Via ArDrive-Core.js. Today, I prepared a small demo application, a little Node TypeScript application that integrates with ArDrive-Core.js. And that is going to go ahead and use the same wallet, the same drive that we were using to show off some RFS functionality and then to build a manifest. So I have just pre-built this application locally to show that it's talking to our drive. You're going to see some familiar outputs of that at the CLI. So we'll go ahead and run that. And it should list our folder right now, our public folder. Okay, so that's listing our public folder. You'll see some familiar JPEGs in here. The Blue's Clues is in there. The What If I Told You is in there. So basically, it's listed our entire folder containing the ArDrive memes. So now we're going to go ahead and change this script and compile it to rather than printing out the contents of the folder, to go ahead and create a new manifest with the contents of that folder. Okay, so we've got some code here. We're going to go ahead and build that. It's using the function on the ArDrive class called upload public manifest. It is providing the ArDrive memes folder ID, and it is providing a manifest name called custom app manifest.json, and we'll be able to see that in ArDrive when we're done. And then it's going to print out the results of interfacing with the ArDrive class to the console. So I'm going to compile that. That's compiled, and we're going to run it, and we will see, that familiar manifest output that we saw from the CLI. There we have it. So our custom application that we wrote and which integrated ArDrive-Core.js just produced a manifest of ArDrive. So in a few moments, this manifest will mine and then bundle at the gateway, and we'll be able to view one of our new friendly named ArDrive memes. We'll go ahead and paste that in the browser. And there we have it. There's Mean Girls. And there is Uno. Voila.
Hey.
All right, well, thanks, Ariel and Andrew. Hopefully you guys are in the crowd, maybe. And we actually have more from them with actually a full demo of the ArDrive platform. Ariel's going through the web, the CLI, as well as ArDrive-Core. Should be on our YouTube page. Maybe it's already there. I'm not 100% sure, but yeah, just trying to produce more content that helps builders understand the ArDrive platform and how to build with it. Because in the end, the extensibility, the added privacy, the composability of RFS can really enable a lot of different things in permaweb apps. Just to maybe go through some things that come to top of mind for me. But if your app needs any kind of attachment feature, RFS is a great choice there, right? Users can attach things to their app. They end up in their ArDrive or vice versa. They have an ArDrive with a bunch of data in it. If your social app needs to, you want to give users the ability to just link or reference any data the user's already uploaded in their drive, that should be pretty straightforward to do with RFS. If your application is going to be very search heavy, or you're going to require a lot of analytics on the data that's uploaded, on-chain analytics for that data that's uploaded. RFS gives you, again, real structured information architecture that you can query and discover things about. If you want your application to be able to share data with other apps, whether it's apps that you're creating or other apps in the ecosystem, RFS is great for that. It's a standard framework. It's open source that anybody can follow. So again, you have the scenario of something getting uploaded through ArDrive that could be surfaced through another app, and vice versa. Arweave file system is made for ArDrive, right? You can argue that ArDrive is a document management platform, or a digital asset management platform, or a records management platform, or any kind of platform that's dealing with, content in that kind of format. There's really lots of them. There's a lot of enterprise platforms that do these kinds of things. So RFS is, I think, a shoo-in for anything that has to generate states of data to be rendered in that way. The fact that manifests are really easy to create and manage with ArDrive makes it a really good option for hosting your websites, whether it's something from WordPress or other static-based sites or React apps. It's just a matter of uploading that data into ArDrive and then just creating a manifest, and then tweaking the CSS or moving certain files around or making changes. It's really easy to just do it to that one file and recreate your manifest. And then, similar to document and records management systems, but maybe you're making a system to manage metaverse assets, right? Or maybe you're, provisioning NFTs for a specific drop, or, a specific metaverse environment. ArDrive makes a great way to categorize that, and give a value add to your users, because now their data is in ArDrive and they can easily go and browse and share that, versus look at a block explorer and just look at the transactions in a wallet. So RFS is, like I was saying before, is built to extend. There's even more things that we want to do with it, and more things that I hope to see the community do. For example, supporting atomic NFTs, right? That metadata, the file metadata transaction could point to an Arweave atomic NFT, or a Koi NFT, or Pianity, for example. Or the metadata that we assign in ArDrive could follow other platforms' metadata standards, like OpenSea, for example. So we're exploring doing these things from the ArDrive side, but they can certainly be custom built as well. We're also looking at expanding the metadata that we collect for ArDrive, for RFS entities, right? We're trying to introduce this concept of an RFS schema, which is really a standard way to define a set of metadata for your files on the permaweb, right? So it's basically a JSON structure of metadata properties, rules, potential default values. They can be public, and figure you can have one single space for information architectures and schemas that anyone can use. I think that can be pretty powerful. Or they could be private. Schemas can enforce this parent-child creative record, and then you have one that inherits it that's called book, and then you have one that inherits that called comic book. So trying to make it really flexible, and then trying to make it so that you can set default schemas for other RFS entities, like a drive or folder. So if you upload something in a specific folder, you're going to have to fill out the schema assigned to it, or else it won't be generated in the drive state. So we do end up with a more complicated entity relationship model, right? But this shows how drives, folders, files, NFTs can all reference that schema entity, right? And those schemas, again, can be public and shared across the whole permaweb. That gives you that one single library of information architecture metadata, or private and unique just to your private drive. I've been looking a lot at like schema.org, for example. There are so many tightly classified things out there. And we're hoping a system like this can bring that into RFS. Of course, other little features as well, right? I mentioned hiding things in ArDrive, integrating with atomic NFTs, introducing these schemas and supporting real advanced metadata, as well as custom GQL tags that can be applied to your transactions. We've thought about, well, there's no social anything in RFS right now. Not sure if that's the place for it, but something else that could be introduced, liking certain files or things like that, as well as increasing the security around sharing. Right now, to share a private file with RFS, you're basically giving the user the file key, right? They're going to have access to that file forever. So ideally, there are other ways around that. It would be great to be able to take access away or give time-boxed access. So, invite people interested in that to, knock on our door, because we would love to talk to you about that. And then finally, introducing drives where multiple users can collaborate, whether public or private. So, we've been on the first version of RFS for a year and a half. It's definitely not going to be the last. And definitely invite anyone interested in this kind of thing to come chat with us, because we would love to co-author updates to future RFS versions. If you want to learn more, of course, you can go to our knowledge base, kb.ardrive.io. All of our code is open source. I'll be able to share this presentation as well in our channels. And thank you, everyone. I appreciate you listening to me. I think I've been talking for, over an hour. If you need help with your project, please let us know. If you're not sure about taking the plunge as a founder, but you still want to build something in Arweave, that's cool too. We have jobs, we have bounties. We would love to set you on the right path. Just reach out and we can work together. And thank you, everyone.
Perfect. Thank you, Phil. You certainly prompted a lot of discussion in the chat. So I think that the mingle session will be really interesting.
Oh boy.
There's a lot going on in here. But thank you so much. That was a great presentation. Everyone, we're going to come down in just a second here. And also remember, tomorrow is the community spotlight, the second one of the Open Web Foundry. And this one will be projects that are currently within this cohort. So if you want to see, the newest projects on the permaweb, come to the event tomorrow at the same time. All right. See you guys down there.